All right, it's a great pleasure to welcome Leah Louisa Maas from the University of Bamberg. Leah is a master's student in the Applied Computer Science program. She was a student of Ute Schmidt, who worked on the IgorII programming induction system. Today, Leah Louisa is going to talk about her experience with making the IgorII system more usable through a web-based interface. Just to put things in context, one of the things to realize is that program synthesis and programming by example is becoming an increasing part of the technology that all the major companies are offering to empower people, to empower them to do tasks, etc. So this work on thinking about how to make it accessible to people, how to explain the results of it, etc. to people is really fundamental in understanding how to make this technology really reach as large an audience as possible. So thank you very much for presenting.
Thank you. All right, so welcome everybody. I want to start things off with talking about inductive programming for a bit. I don't know if every one of you is familiar with the concept. Induction in mathematics describes inferences from particular cases to the general. And in computer science, inductive programming is basically the same. It uses a set of specific equations to generate universal functions. This principle is useful when repetitive tasks have to be performed. So the developer does not need to implement the functionality each time by hand, and therefore has time for more complex tasks. In addition to the set of those example equations, information like background knowledge can be given to the inductive programming system. So the computation of functions may take less time and is thereby more efficient. The functions that are being generated are often recursive. As you can see in this example, we have three examples for a function called last. For last with the input a, it should have a as an output. For an input ab, it should have b. And for an input abc, it should have c. So the function should always return the last element of the list. With inductive programming, we get this function that is applicable for every possible input. So if the input has one element, then this one element is just returned. And if the input has more than one element, then the function is called recursively with the list, but without the first element of this list. One of these inductive programming systems is IgorII, which was implemented by the University of Bamberg in the programming language Mod. IgorII generates hypotheses based on input-output examples, and those hypotheses are mod functions. IgorII usually needs approximately 4 input-output examples to derive those hypotheses, and it works with previously defined internal data types. So the programming language Mod itself has data types, but IgorII needs special data types, which are also defined within IgorII. IgorII, the algorithm, can be described as a uniform cost search, which means that the hypotheses with minimal costs are used for replacement and are returned by IgorII. Now let's talk about the usage of IgorII. I mentioned earlier that IgorII basically only needs input-output examples, but when you look more closely, it's much more difficult and much more that is needed. IgorII needs an input file, which is a mod module. Within this mod module, you have to define the module name and the sorts that are needed for the function you want to generate. So for the example last, my item and my list are needed, which are both IgorII internal data types. And after that, you have to define the constructors for these data types. So you have the constructor for the empty list and the constructor for every other list, which takes an item and a list, appends the item to the list, and then returns the list. In line 9, you can see the definition of the function last. The input is of type myList, and the output is of type myItem. In addition to all that, here are the input-output examples, which basically should be the only thing the user should provide, but in reality isn't. You have the variables, x, y, z, which are of type myItem, and then you have the 3 example functions. Once you have this input file,
Could you go back to the previous slide? What was the invec and the operator in? Where
here
it
in
was used, yeah.
line 11, that's just something that IgorII needs, which is IgorII specific. So this has to be stated in every file.
Oh, and it's not used in the next slide at all, even though.
No, not
Okay.
really. Okay.
Okay, thanks.
Okay, so once you have this input file, you can then call a reduce command, which is in mod. You say that you want to reduce in Igor, the module last and the function last. This no name means that you provide no background knowledge, because for the function last, no background knowledge is needed. But if you would need some background knowledge, you would put in the function name there. Down here is the output that IgorII generates. You can see the number of rewrites it took to generate these hypotheses and the time it took. And those here are the hypotheses. As you can see, they are in IgorII syntax and are not that easily to read. And you cannot test the function this way because it's not mod code. So you would have to translate it. If you translate it, you can then test the hypothesis by calling again a reduce command. You want to reduce in the module last, and then you have to put in the function call. After that, mod returns as a result my item D, which would be correct for this input.
So the input to the tool can only be equalities, like input-output examples, or can you also have some other predicates?
No, only input-output examples. If you want to know more about IgorII, you can read those two papers. And the source code of IgorII can be downloaded at this address.
Sorry, can you go back one slide again?
Mm-hmm.
Is it important at all that it looks like the hypotheses that came up with don't match the ones that you'd shown in the previous slides, because it looks like it's either saying that it's a 1-item list or a 3-item. Oh, I see. No, X2 could be nothing. Okay. Yeah, okay.
Okay. So now that you've seen how IgorII works, this leads me to a question. IgorII, is it usable for everyone? Well, first of all, it requires knowledge of constructor terms. In addition, the interaction is only possible via terminal, and one has to call mod commands. So the normal user might not be familiar with using the terminal and might also not know how to write lists as constructor terms and so on. So interaction with IgorII needs to be much more intuitive.
So who's the user in your mind?
Basically everyone, maybe software developers, which might be familiar with these constructor terms, but also the data types are IgorII internal, so maybe they won't know them. But basically everyone who wants to derive functions or who's interested in inductive programming and maybe wants to try out the system. So the solution is EasyEgo, which is the web-based frontend I've developed. You can see here that the user can put in the function name, the input, the output, and then just has to state the data type. I will show this in more detail later on with a live demo. But now I just want to talk about how EasyEgo works. So here we have an overview. You have the user, and the user interacts with EasyEgo via an interface. And EasyEgo has two main components, the translator and the tester. The user types in the input-output examples, and then the translator translates them, and then calls Igor, which in turn returns the hypothesis. These hypotheses have then to be translated again and are shown to the user. And in addition, they are being saved as a mod module because they are needed for testing purposes later on. If the user now wants to test the hypotheses that were being returned, he can call an example function call, which is then being translated by the tester, and then being called by mod with the use of this mod module that was written previously by the translator. Mod then returns the result of the function call, and then the translated result is displayed to the user via the interface, and the user can see whether or not the hypotheses were correct. Before I talk about the algorithms, I just want to say some words about the data types. Here we have 4 data types, 2 lists, integer and Boolean. So this list contains items, and this contains integers. This is the way the user can put them in EasyEGOR, and this would be the way the user would have to put them in if the user would use Igor 2 directly. So instead of using this const terms or this successor of 0 terms, the user can just put in the list like this, or put in an integer like this. To make this possible, a few algorithms had to be implemented. This algorithm is to transform a list that contains items. So first of all, the converted list is being initialized as an empty list. And then the items are the elements that are being extracted from the list to convert. So in this case, the brackets and the commas are removed, and then only the items are being left. After that, the algorithm iterates over the items, and for each item, the item is appended to the converted list with this constructor terms. So you have cons, then the item, and then here is a placeholder where you can put in the next cons and the next item. At the end, when every item has been appended, the converted list is being returned. Another algorithm is to transform integers. To do so, first a variable called converted nut is being initialized with 0. And after that, for I between 0 and the nut that is supposed to be converted, the converted nut is being surrounded by s and by brackets. So at the end, you get as many s and brackets as the number that was being put in. Now, when you have converted the input, you have to save it in a file. For this, I have a file template. All that is written in caps is being replaced, either by directly with the user input. So for example, the function name can be directly replaced by the user input. But some things aren't given by the users, for example, the sort constructors, and they are being taken from a file that is being provided. So if in the needed sorts there's, for example, a list, then the list constructors are being written here. After the examples are being saved in this file template and the hypotheses are being returned, the hypotheses have to be translated to make them testable. So at the top is the return of Igor 2, and at the bottom is the translated version in mod syntax. So basically, you replace every x that has a number after it and the data type. So for the first hypothesis, x0 my item gets replaced by a in both cases. And in the second hypothesis, you have x0 my item that's being replaced by b, x1 my item by a, and x2 my list by g. After you have replaced this, then the hypothesis can be tested. So, yes?
So what is it being translated into? This is coming from Igor into mod, or what?
Yeah, exactly. Because this cannot be tested directly, it has to be translated. After it was translated, then the user can put in the example function call, which then again has to be translated because he would put in the list in his fashion and not in Igor 2 syntax. And then the function would be called, but the return of the function also has to be translated, because it could be that the function the user wants to test returns a list, and this list also has to be translated into this non-constructor term fashion so the user understands it. For this, there are algorithms within the tester. This algorithm is to translate a list from Igor to a syntax the user can understand. This is done by, again, initializing a variable converted list with an empty list. And then the elements from the list that's supposed to be converted are being stored in an items list. This is done by removing the punctuations and the cons, so only the items are being left. After that, the algorithm iterates over the items and appends each item to the converted list and then returns the converted list. The algorithm for transforming an integer.
Isn't that going to reverse the list? Because you're sticking the item at the end? Or you're walking through items from the front?
But you have the converted list and then you just append the item.
Right.
So
you're
A is the first
post-pending-
item.
Oh, I see. Yeah, all right.
And then you just, okay. Yeah, the transformation of an integer. You have the variable count that is being initialized as 0. And then for I between 0 and the length of the integer that is to be converted, which is a string, the algorithm checks if the character at position I equals S. And if that's the case, then the count is being increased by 1. So what the algorithm basically does is count the S in the string and then just return the number.
So if you're dealing with large integers, do you have to like have a super long string?
Yeah, it's really, really long strings.
And is there a way of supporting floating point numbers?
I don't think so. I don't think that IgorII can deal with floating point numbers. Okay, so now that you've seen how EasyEgo works, I want to draw a conclusion and talk about future work. EasyEgo allows for intuitive interaction with IgorII, but it also has to be said that it only supports a subset of functionalities of IgorII at the moment. Subset because only one input variable at this moment is possible. So if you want to derive a function that has more than one input argument, that's not possible. And in addition, it's at this moment also not possible to provide background knowledge, which are both features that are implemented in IgorII, but not yet in EasyEgo.
So what kind of background knowledge would could you provide in IgorII, and how would that translate to what the user specified? Can you give an example?
The background knowledge can be any function. You have to provide the function again in this file, input file, and maybe it can be the reverse const. So instead of appending an item to a list, it's to put it at the front. So that can be some background knowledge, a function that does that, and then it can be used, I think, for the reverse function. So then you get a reverse function with lesser equations,
So
lesser
it becomes
number.
Part of the things that Igor explores that potentially solve, meet the set. So it becomes the sort of that function then becomes one of the ground terms in the resulting Igor synthesis. Okay.
Okay. So future extensions for EasyEgo would be additional data types. For example, an embedded list, which is a list containing lists. In addition, background knowledge, which would be useful for more complex functions. And it should be possible to have functions with more than one input variable. So those are all things that should be done in the future to improve EasyEgo and the way it works. Now I would like to give you a short live demo of EasyEgo. EasyEgo can be reached under this address and can be tested. Let's see. Okay, so this is the web interface. Then you can just type in a function, for example, last. And then you have to state the input and the output for each of the examples you want to give. So let's say we have a list with a different number of elements. And after having put in the input.
So what does the select for the data type do? What does that say? What data type you're telling it about?
It's the
type of the input?
type of the input, yeah.
Okay, so you haven't selected list of alpha, right?
Not yet. I was
Okay,
getting
that's
to
okay.
that.
You're going to get to it, okay.
Yeah, so here are the different data types. So you have integer, lists with integer, list alpha, objects, and bool. So in this case, the input would be list alpha, and the output would be of type object. Then you can just submit and see if it works. Okay, so this is what IgorII returns, already translated into mod syntax. Here you have the variables, which are my item A and B, and my list G. And down here you have the equations, which is here a list containing only one element, and here a list containing an element followed by a list containing an element. Now if you want to check if this is correct, you can just click Test Hypothesis, and then you can put in an example call. Okay, so you have the function name and then the input, which is a list A, B, C, D, E, F. And then you can test the hypothesis. And you can see that the result is my item F.
So if we go back and sort of, can you give an example where there are two competing hypotheses which might be correct?
Mm-hmm.
So for example, if you had a list of 3 elements, and you always basically pick last element, and now the choice could be it is the third index or it is the last index. So what would it be?
Can you repeat the question?
So so let's basically put in inputs where there are lists which have all the lists have 3 elements.
Mm-hmm.
And we will sort of, the output will be the last element, but now there is an alternative hypothesis, which is that the third element is the output.
Okay.
So I want to find out whether the system sort of gets the last one or basically finds out whether it's the third one.
Okay. So like this, you mean, right?
Yes.
Okay.
Let's just give 2 examples and see what.
Mm-hmm.
She already said it needs 4.
Approximately.
It's
So
learning the tool
depends.
by example, reversing engineering.
So what did it
Okay, so it looks like it's always returning the third element.
Or an element.
I see. Okay, now can we
Well,
add?
actually, though, so with that particular formulation, what if the list has more than 4 elements, or more than 3 elements?
You're just silent about the behavior on others, right?
Yeah.
Partial
So
function.
so do a test hypothesis on that. I
Mhm.
just want to see if you give it 4, what happens?
Okay, so it's not able to
I
solve
can't
this.
resolve it. Okay. Yeah.
So is Igor always using recursion? Is that the only way it finds
Yeah,
solutions?
basically.
If can it handle? Oh, it cannot handle. It cannot handle strings. Okay.
Well, list of words. Can it handle strings and list of words?
No, objects in this case only means like variables A, B, C, D, so the alphabet.
We can simulate that using a list. Maybe you want to do first name, last name with this. Or?
Yeah.
Okay, we can try
Or
that.
no, I wanted to add a constant at Microsoft or something.
Okay. Yes, so what happens if the input is a list and we want to add some constant sequence of elements at the end? So the example would be, let's say input is ABC.
And output is basically A Microsoft, B Microsoft, C Microsoft.
No, so you cannot change constants, I think, right?
Yeah,
so
that's
whatever.
So
Just
just
have
add
AD.
Yeah, just add, MICRO at the end. So ABC, and then we'll add MICRO. No, the output is ABC.
Yeah, it's the same list as
the same list,
Yeah.
and yeah.
And then we'll add, Microsoft at the end, M, comma, I, comma,
Or just,
Yeah.
or just,
Whatever.
M. Yeah.
Yeah, just one more, yeah.
Just M is fine.
Yeah.
Okay.
Yeah.
So you
let's
always
have 2 elements. Let's see what
Yeah.
happens.
Alright,
M,
sure.
I.
Yeah.
Okay.
2 is not, non-trivial generalization.
And D,
No,
yeah.
the great thing about this is that instead of learning Igor to do this, you can just type it in. Yeah.
You need a function name.
Mm-hmm.
Writing MI.
Okay, so this doesn't seem to work. I don't get any variables or equations.
Let's see.
I guess maybe the reason is that probably needs a binding for M and I, and there's no scope for constants here now.
Okay, maybe that.
Or maybe that she was saying it might take 4, and we might have to give more
Oh,
examples.
maybe you can give more, yes.
No, my sense is that M and I are not bound to anything.
Yeah, what if you
Yeah.
said ABC, AB as
Can-
the output?
Yeah. ABC, AB, and DF, DE.
Yeah,
No, no, no.
No,
Repeat the input list,
add
but just add the
ABC,
last.
ABC, AB. So have the outputs has
Five
five,
elements.
5 elements. ABC, AB, and DF, DE.
right, so that way we're not.
Yeah.
Extend the domain.
So all this fun-
GHI,
Missing one, dude.
GHI, GH.
Or get rid of it. You gotta
Oh,
throw it
there's
out.
one output which is missing.
Oh.
Yeah, GHI.
Yeah, right.
Yeah, that's correct. Right.
Seems like you should translate, as long as you're doing all
Yeah.
this translation, you should translate the equations up there, right? Because you're showing it in a syntax that's not the one the user
Yeah,
is writing.
so maybe that's also future work to just change that.
Yeah.
But this seems to
Yeah, it
work.
works. So does it general? Well, I guess.
You
it's
got an
right.
extra comma at the end of the.
Okay, just gonna show one more example. Not reserve, reverse.
Spelled it right well. Can you do it just with the 2? It's been working with 2 examples.
Okay, but this would only work for
Yeah,
list of 1 and
exactly,
2. Yeah.
Interesting.
Right, I get it. Yeah. So you need the third example to generalize to
Yeah.
an arbitrary number.
Let's see if
If,
Three is
why
enough.
not this one? So how long can the
Oh, this is
yeah? So now it's what there is.
Yeah, so these are a lot of equations. That's what I said earlier, that with background knowledge, it won't be as many equations because, yeah, you have a lot of sub-functions now. So,
So is that the general solution for reverse, or is that still limited to a fixed number of inputs?
We can test hypothesis.
that's the general solution, I think.
Now the test hypothesis button actually makes sense because it's not clear whether is it wrong.
Yeah, exactly. Like what?
Some 1 and some 2. So 1 is gonna.
So I think even if you prove this and so on, there is a stage where the programs do get unreadable.
Yeah.
Then you trust.
Yeah.
Yeah, it is a leap to the generalization, right? And whether or not that becomes simple, like I mean, I guess reverse is not trivial to write in any case, right?
if I put in, which is kind of interesting because if I put in 4 examples, because I've tried this earlier. Then it states that IgorII has generated more than one hypothesis. So I don't know why it works with 3 but not with 4, but it seems like when you have these 4 input-output examples, then there's more than one set of hypotheses with the same cost, so Igor does not know which one to return. So in this case, it helps to just put in the empty list as some sort of base case, and then if you submit it again, you get the same equations as before, but with this base case in addition. So interesting that it works with 3 examples, but not with 4.
So the thing it generates is like a partial function over the domain. Like, so we saw an example where in this one where there were inputs where it didn't have a result. Is there any way to tell the user that it's a partial function, or that you need more inputs to get a complete function?
Yeah, I mean, it stated earlier that it needed more inputs. I don't know why when we put in the other examples that it was just blank.
No,
Because normally-
when you did last,
Mm-hmm.
it came up with a
with a
definition that was
partial.
only a partial function. But the user isn't told, like it didn't work for
Yeah,
emptiness.
I don't think that you can really tell just by getting the hypothesis back, because IgorII doesn't say that it's only a partial function. So that might be something to improve, but I mean, the user would see when testing the hypothesis that it won't work, so there's that.
So what are sort of the set of operators that IgorII searches over? Is it just these primitive lists, cons, and
Yeah, basically, I think IgorII can also deal with objects and other data types. I think that the university has tried the towers of Hanoi with IgorII, but that won't work with EasyEgo at the moment, but it's also something that can be thought about in the future, because I think IgorII is much more powerful, but it's kind of complicated to just start and work with IgorII, because there's a lot you have to consider. So
And these examples are noise-free, right? Are assumed to be noise-free.
what do you mean by that?
If there is any error in the output, then it will not work, right? It's not robust to errors.
No, I don't think so.
Okay. Can we do a natural example and see it can do regression? It can do linear regression.
Maybe. I don't know. Let's just.
So I don't know. Let's pick some.
Y equals 3x plus 1?
3x plus 1. Okay.
Okay, I don't think that would work actually, because what data type would it be if you just
It would
put
be
in?
nat to nat,
Natural.
right?
So it will be.
So the input would be
X
input
is
would be
equal to-
like 1, 4,
Okay.
2,
Yeah.
2, 7, right?
Yeah. Maybe it cannot do multiplication or something. You can do addition.
Yeah, maybe that might be the case.
Maybe you could do two, like two,
Yeah, try
I mean,
three,
it could
four.
learn, but that could be done with addition, so just x plus x plus x instead of 3x.
Yeah, but that would be
That's,
longer,
that's
right?
a big
But you
formula,
have to.
yeah.
Trying to
Maybe.
reverse engineer the algorithm by examples.
Exactly.
Yeah, maybe in the output you can replace 4, 7, 10 by 2, 3, 4.
Yeah, just to say that learns plus 1.
Yeah. Yeah.
Okay, so
Add one.
that works. Yeah.
But Is there a multiply? Maybe yeah, there is no multiply.
I guess the multiply because the successor notation or representation.
Yeah, that
becomes
might be
very
difficult to do
complicated.
by, yeah.
I think multiply might work in the recursion. So let's try that. Just it's like 2 goes to 4, 3 goes to 6.
A pure multiply. Okay. So
Just
yeah.
a
So
simple
then
one,
replace
two,
3
one,
with
two,
4
four,
and so
Yeah,
on the
Two-
second
2 goes
output.
to 4.
On the second output, yes,
yeah.
4 and here 6.
Okay. Doesn't seem to
Maybe
work.
in the same
so-
session, because you reused the same function name, is it the same? So this is generating WAR files in the background?
Normally it should override it, but
Okay.
Yeah.
I don't know, I can try, but I don't think.
Mul2 actually.
Yeah.
It uses that.
Okay. Yeah, I think it's limited to simple addition.
So it's almost like symbolic. It's like these successors are like an ordering of symbols.
Yeah.
And then it's symbol manipulation.
Can it do regexes? Regular expressions,
Mm-mm.
basically.
I don't think so. EasyEgo can't. I don't know if Igor2 can. So
How about counting? Counting the number of A in the list, for instance. Things like that. Can you do that?
That's a
Um,
good one. Yeah.
I don't know. I haven't tried it actually. So like counting the number of elements in the list.
No,
Number of A's.
Yeah, so
Number
maybe
of
let's give large lists, maybe A, B, C, D, A, B, C, D, and then
A, B, C, D, A.
yeah, C, D, A, and then get 3. We put another A there.
Mm-hmm.
Yeah. And
Will Sketch be able to do this? So
So if the mod syntax is so terrible and you
I'm pretty
have
sure
these nice translators, why doesn't mod just
Use
issue
it directly.
translators?
Mod is not terrible per se. It's more like the Igor2 data types that are kind of difficult. But mod also is yeah, not so pretty as a language. But
Okay, or Igor, I guess
Is
you
mod,
could change
is
the
mod developed by Ken McMillan? Is that his work, or is it a different mod? I think
No.
it's not the same. Okay. Okay.
It's from UIUC, right? Etc.
Greg.
That would be hard to learn that just for these 3 examples, right?
yeah, I'm not even sure if it would work.
what happens if you change this with bool? If you put bool there and just put 0, 1, presence or absence of A, or I don't
Sure,
know,
false,
B,
yeah.
presence or absence of B. Yeah, so this is false. And then and yeah, this is unique, right? Could be a unique item.
No.
Maybe reduce the list size.
I think maybe this would work if you have more than one input argument. So maybe you can have as a second input argument the character it should look for. So that's maybe something that Igor2 can do, but with EasyEgo right now it's not possible.
Yeah, there's an implicit argument. Okay. Yeah. Anything else? Okay. Let's thank the speaker.
Thank you.